Rightio, steering box conversions. This is going to be specifically for Land Rovers, but there'll be a little bit of information on the GU box that might help other people like the Toyota guys swapping their Nissan boxes in. A couple of reasons why people will do a steering box conversion. One is to create room for an engine conversion. The standard Land Rover 4-bolt, as found in Defenders and Disco 1s, I believe, ran for many years, made by Adwest. It runs down the sector shaft and gearbox ratio arrangement for that runs down the inside of the chassis rail, whereas the GU and the P38 Range Rover both run on the outside of the chassis rail. The gearbox that's in line, the input gearbox or worm, is on top of the chassis rail in all cases. So creating room for engine conversion, and the other reason is strength. You know, if people are putting big tyres on, doing some comps or whatever, and they're having issues with the Land Rover box failing, whether it's the sector shaft or the worm and wheel flat spotting, they're often looking for a strength increase. In the UK and Europe, or especially the UK, the P38's quite a common conversion because it's readily available, whereas the Nissan boxes aren't as readily available, and the opposite here in Australia, heaps of Nissan boxes and not as many P38 boxes. And without having pulled them apart and seeing the internals, both of these are stronger than the Adwest Defender box or standard Land Rover box. I would hedge my bets on the Nissan box being a bit stronger than the ZF for the P38. It might not be much. These are definitely a stout box, but you know, these are a bit of a beast. But these are by all accounts pretty good option for a strength increase. Some of you may know, right at the end of the Defender run, the original Land Rover Defender run, which ended in 2016, and I can't remember whether it was right at the end or after the end, Land Rover themselves, the factory Land Rover, were building bespoke Defenders. I believe they were buying used Defenders to get the VIN that they could for emissions. But anyway, they were called Works Defenders. They put the Jaguar Rover multicam modern V8 in it with a 8-speed auto, I believe, behind it, and they're about 150,000 pounds new from the factory. When they did those, they actually installed a P38 box themselves, and quite a good little setup, the way they attached it and made the bracketry for the drag link and the panhard and for the mount for that, and the panhard and a brace back to the other side of the chassis rail. But again, a lot of people are swapping these in. There's kits on the market where you can buy a kit that gives you a bracket and mounting, and you do a little bit of mod and you install the whole thing. And for most of the blokes doing a GU box, it's going to be one-off, complete, do-it-yourself sort of thing. So there is some things to consider when swapping in a steering box. And I tried to find out online. I asked questions, I researched, and I couldn't find much information about these boxes as far as what I think is important to us as far as just the steering box goes. And then the other thing will be the steering geometry, and we'll get into that as well. So as far as the steering box goes, I wanted to know, is it the same ratio as my Defender box, or faster or slower? And the other thing was the Pitman arms. The different lengths of the Pitman arms will create a different sweep and how much it travels. So the ratio will kind of be a speed thing, like the feel of your steering for speed, and then combined with that, because a shorter arm is going to have a shorter sweep, whereas a longer arm will come around more. So for every degree of rotation, they all might have 1 degree of rotation, but the one with the longest arm, let's say for example they were all the same ratio, the one with the longest arm is going to travel more because it's further away from the pivot point. So I've taken some measurements of all these boxes, and it mightn't be the most correct way to do it, but I made sure they were all exactly the same. So they are in reference to each other. I made it as scientific as I could, you know, not quite the level of putting liquid paper on a bee, but I tried to get there. So I'll run you through some numbers of these boxes. So just a little bit closer look. This is the Nissan GU Patrol, or Y61 as they're often referred to, as now so, but more so overseas. These are made in Japan by Koyo, and the number on the side of these is 104. I believe there's an 83 or something. The older boxes on the GQ Patrols, the Y60s, aren't as strong, and they're not as good, and those guys are swapping these in as well. Then we've got the P38. This was the P38 Range Rover that came out in about 1994 or something. So it was the very first new generation Range Rover after the original. The original Range Rover ran from 1970 right through, obviously with updates and upgrades and facelifts and all these things, but from 1970 right through to 1993 or something like that. And I think it was still available for a couple of years even after they released the P38, but that's the new P38, or the new Range Rover P38 was the variant code for that vehicle, and that's made by ZF, and they're meant to be a pretty good box themselves. And that's the old tried and true 4-bolt made by Adwest Defender box. Now it looks like, so these are all right-hand drive steering boxes. These two are on the outside of the chassis rail. This one would be flipped, and the vertical section with the sector shaft would be on the inside, and the Pitman arm would be facing forward as well. And the input shaft and spline for the uni would be on that side, the same as those. It just sits nicer like that, and that probably gives you guys a bit better idea. So first of all, weight. So weight's probably the least important, but it's something to factor in. Often doesn't get considered, but these are outboard the spring. They're not in between the front axle and the rear axle, so they're definitely going to make a difference hanging off the front of your car. So the Nissan's the heaviest, no surprises there. It's 20.7 kilos, and these are weighed as are, so they've all got a Pitman arm on them. The only difference is I didn't have a uni on this one, so that's aluminium. That's going to be pretty light, not too bad. And this is not sort of crazy, so take it for what it is. It's the best I could do. 20.7 on the GU, or the Koyo box, the Nissan box. 18.8 kilos for the P38 box, and 17.3 for the Adwest Defender Land Rover box. So yes, you can equate weight to strength, absolutely, but that's not always the case, and we don't know how much of a strength because of weight, but that's just the weight of them. That's what they are. Some other measurements that are interesting is from the nose here back to here. I've kept it the same point on all of them, because on a Defender, and mine's currently under the knife, but you do have the panhard bracket here, and then there is a gusset on the back of the front spring perch, which is incredibly important, and I've cut it off, but it will be reinstated, so ignore that. Just pretend there's a little gusset in there. So you've got to fit in here. Now, whether or not you're cutting that off or what you're doing, that's up to you. I will make this comment now, and I might touch on it again later. This stiffener down here on the gusset or of the leg of the spring perch, and these gussets, any of that strengthening stuff on those front spring perches on a Land Rover is incredibly important. Cut it or grind it or remove some of it at your own peril. I can just say that, because some of the kits, I believe, require you to relieve some of that. I would be very wary, and if you have to, maybe look at how you can reinstate it somewhere or somehow to make up for that lost material, because lots of fatigue, lots of load on and off, and those gussets are and stiffeners are very important part of that design. So that's that said. But you've got an area here where the barrel has to fit on top of the chassis rail, and these are noticeably bigger. So the Nissan from snout to uni point there is 285 mil long. The P38 from the same point to there is 295 mil long, and the little old 4-bolt is 195 mil long. So this is at its point there to there. So this is a good 100 mil or 4 inches for the North American people, shorter and fitting in better in that location. A quick word on the geometry. You can see they're all sort of different heights and whatnot. Obviously you can't mount them any lower than this sitting, this part of the housing or gearbox sitting on the chassis rail or within, you know, that 3mm clearance or whatever you're going to allow. So there's going to have to be some adaptation and chassis modifications to make these fit, absolutely. I'm not going to get into that as in how to do it. That's up to each individual. Obviously this one just bolts in, so that's fine. We don't have any issues there. The different heights of, you know, straight away you'll notice this is a straight pitman arm, this is a cranked, and this is a cranked. What's important is when it's mounted in the vehicle, where is that pivot point for the pitman arm? You know, so, and yes, these ones did have a straight pitman arm as well, but you'll notice the built-in tie rod end here is coming up with the straight D1 or this first Discovery variant coming out. The tie rod end drops through and comes on the other side. So essentially the drag link is in the same position. It's the same geometry. So that's why you can swap them back and forth and there's no real issues. And a lot of people go to the straight pitman arm because they feel there's a little bit better clearance and less issues. And plus this is a bit of a bugger to rebuild in situ in this arm. Whereas the other one, you just take the tie rod end out and fit it. So that's fine. So, there's not that I know of different pitman. I can't speak for the Nissan. I don't think there is. If there is, that's great, and that will give some more options. If there's a different pitman arm and it changes the height, that's more to do with the geometry of the, you know, drag link versus panhard. And like I said, we'll get into that. As far as the steering box speed and travel length, it doesn't care what shape the pitman arm is. All it cares about is the distance from the center of the sector shaft to the center of the tie rod end, that horizontal measurement. So don't worry about the shape. That does not change the swing or travel, and it won't change the speed. It's only the distance from the pivot point, which is the sector shaft, out to the center and pivot point of the drag link. So they're different shapes. They just are what they are. This spline diameter here, measured with some calipers, is very close to the ZF. Now, from what I've read, these are definitely a stronger sector shaft and worm and wheel setup. So maybe it's material, or maybe there's some design benefits there. I haven't pulled these apart enough to see, but I'm not going to say that they're the same and you can just swap pitman arms around. I sort of looked that up. I couldn't find anything on it. And I don't think that's the case, because I think if guys were swapping these in their Land Rovers, and I know that people do lose steering lock at the wheels, at the actual road wheels, they would be putting in a longer pitman arm. And so I suspect that these are not the same spline type and size, so you can't just swap pitman arms, which is a shame. And then the Nissan's going to be completely different to the Land Rover and ZF stuff. So a note on that, you might be thinking, well, I can just make my own pitman arm to whatever I want. That's fantastic. It is. There's absolutely 1,000 different ways you could, you know, a few different ways you could make a pitman arm to suit yourself. Here in Australia, it's absolutely illegal. There is no allowance for fabricating, cutting and shunting a pitman arm. What you would need to do is have it one solid piece with no cutting or welding, broach the spline and drill and ream and shape, or get the right taper for the tie rod end. So you might have the capabilities of doing that, but the vast majority of people don't. So that's just a note. If other parts of the world, you might be able to, you know, cut this off and extend it, whatever, great, that's fantastic. That might work for you. Kudos, that's cool. So we've talked about the weight, heaviest through to lightest. The biggest this way, the P38 is the biggest, but that's only a centimetre, half an inch or 10 mil smaller, and then that's obviously, you know, a lot shorter. What I did with these was I set up a bit of RHS, but I set it up on the bench here, set up higher, exactly parallel and in flush plane with the bench. So I had a point that I could bolt or clamp the steering boxes to, each one at a time, and then I had a reference plane to measure off. So in doing that, I was able to turn one revolution at the input shaft and measure how much the actual drag link would move at the pivot point, so of the drag link. So what I did was, when the steering box was all clamped in, and they all have machined surfaces, so they were clamped to that as they would be on the chassis rail. And then I made sure that the drag link on each one, the center of the sector shaft, the pivot of the actual sector shaft, the distance off this bench here, I made sure that the center of each pivot point was set to that, and that was my starting point. And then I turned it 1 revolution on the input, and then measured again and deducted the difference that it started at. And that gave me amount of travel perpendicular to the steering box. The caveat to that is, where they were set is not the straight ahead steering position, because it's not, straight ahead steering is going to be in the center. If you've got 4 full rotations from lock to lock, it should be, the steering box should be at 2 rotations either way, and that's where the Pitman arm should be set for the center of steering. So you've got equal steering left and right. Because of how the limited resources I have to measure it, that was where it was. It's not going to be, a full turn off center, I don't believe, but at least they were all the same. So the variables are all the same there. So starting with the Adwest 4-bolt box, 1 revolution gave us 61 mil of perpendicular travel. The P38 box actually had 62 to 62.5 mil travel, and the Nissan had 58. So they're all pretty close, but the Nissan's a little bit shorter in the travel. Just to comment on that, with the amount of travel per revolution, the Pitman arm lengths. Now, when I say length, from center to center in a horizontal plane, that's all the steering rotational geometry cares about. So the Adwest is 183 from center to center. The P38 is 155, so it's shorter, 155 center to center, and the Nissan is 157 center to center. So they're pretty close as far as the length of the Pitman arms. This is, nearly 30 mils longer, so it's going to give more throw, especially from the straight ahead position, because at the straight ahead position on your vehicle, when you're going dead straight down the road, most vehicles are going to have the Pitman arm somewhat perpendicular to the drag length. So your drag length's coming in horizontal across your vehicle, and the Pitman arm's going to be straight forward, and they're going to be nearly 90 degrees. It's not going to be bang on 90, but it's going to be somewhere around there. So that initial input of steering is going to be the most amount of travel per revolution. And what I mean by that is, as the drag length starts to keep turning, even though you're going 1 revolution, another revolution, the gear ratio doesn't change in the box. It's not a variable ratio, as far as I know, and I could be wrong about that. So if I am, please comment. But as that Pitman arm swings around and becomes more parallel with the drag link, the amount of travel pushing sideways, so pushing the wheel out, is reduced, because 1 revolution turns X amount of degrees. If we think of a circle, the shaft is, spherical, obviously, and we're turning a steering wheel. Everything's just is a rotational point. From here to here, and it's pushing something that way. If I'm here to here, I haven't changed length this much at all. So that sort of comes down to the length of the arm starts to lose. So this first section here, the longer the arm, the more it's going to swing. As we come around, the longer the arm doesn't really make too much difference, but what will be the gear ratio of the box. So speaking of ratios, the Adwest box takes 3.75 turns to go from full left lock to full right lock. So 3.75. Now forget the travel of the arm, that is literally just the gears, how far they can go from stop to stop, the internal stops in the box. So 3.75 for the Adwest, 3.7. So I'm sorry, I didn't measure the actual degrees of rotation, and that would be nice to know. I'm sort of just doing this as a thing on the side, just for whatever. But if they do turn the same amount, but that takes 3.7 turns. That's slightly faster. The ratio on that will be slightly faster because we get there quicker. And the patrol box takes 4.25 or 4.25 turns. So I feel it's a bit slower, and between the number of turns and the total travel, yeah, I just felt that it was a bit slower ratio box, and that's sort of going to affect your feel, you know, because when you input how quickly your road wheels turn as you're driving down the road, and then total travel is obviously feel if you're moving, but if you're moving slowly, it's more like how much steering lock do you get. And steering lock can be affected by other things outside the geometry, like do the wheels and tyre rub on components, so you've got to have your actual steering stops at your wheel assemblies further out, so you don't actually get to use the full range of your box. So there's a whole lot of variables there, but at this stage, I think the Nissan's a little bit slower in its ratio, and then with its Pitman arm as well, sort of combined. Now, total movement, perpendicular from lock to lock. So because I couldn't do it here on this setup, the Pitman arm would swing around and hit the bench. I set the RHS up in the vise and clamped from there, and used this face here because that's where we were clamped nice and firm and flush and everything with there. And then I use that as a reference to measure the Pitman arm. So total travel from full lock left to full lock right. The Adwest box gave us 230 mil travel. The P38, 208. So, you know, 22 mil less travel from, so, you know, what's that, 11 mil less left and right sides, but 230, 208, and then the Nissan came back with 220. So it might have a bit more internal rotation, but that's what it is. So those things are, you know, you might think, oh, they're all pretty close, but they will affect the feel and the speed of the steering input. So you don't want to be too far. If you're used to this and you like this, well, you know, you don't want to be too far away. Obviously Land Rover deemed it okay because they fitted these. I'll have to dig up some photos and just see if the Pitman arm they used on the Defenders looks the same as that. I won't be able to measure anything, but if it's cranked, then we know it's completely different, but that's a starting point. So there's some numbers there. They might not mean anything, but you know, they kind of do, and they did to me. And I was a bit like, I didn't want to lose steering lock, especially on a Defender. They're not fantastic. They're not the best in the world, but I wanted to be able to have my full steering lock, and I didn't want it to have slower steering because, again, it's not a race car, but I don't want it to be worse than it is and slower and vague. So, or require heaps more input at the wheel, you know. So, so that was the base. You know, everything's based around what is this as the basis point, or you know, the benchmark, so to speak, and then go from there. So the other part of geometry that's really important is the relationship between the drag link and the panhard. So whether it's a Range Rover Classic, a P38 Range Rover, a Defender, a Disco 1, a Disco 2, a Nissan Patrol, GQ, GU, 80 Series Land Cruiser, 105 Series Land Cruiser, 79 Series Land Cruiser, all those vehicles have coil spring front suspension. They all have radius arms as the suspension links from the axle housing to the chassis, and that controls fore and aft location and torque reaction, whether it's acceleration torque or brake torque. And then the panhard is what locates the axle housing laterally, so left to right, and that's a very important link. It also dictates the roll center, but as far as the steering goes, the relationship between the panhard and the drag link is very, very crucial, so we don't get bump steer. Now, you're not going to, I mean, I haven't measured a Patrol or a Cruiser, but given the physical limitations, I'm going to say that they're going to be the same as a Land Rover in the sense that the panhard's shorter and the drag link's longer. That's just how it is. In a perfect world, they'd be exactly the same length, and they would be exactly the same plane, parallel when you're looking down from above and parallel when you're looking from in front, and exactly the same length. And every time you would go over a bump, any arc that they scribe, because remember they're pivoting on one end, so they don't move up and down parallel, they're actually pivoting. The arc that both the Panhard and the Draglink Scribe would be exactly the same, and therefore the steering arm on the swivel housing moves in unison with the axle housing as it swings in an arc, and you get no steering input when you're going over a bump. The only steering input you want is from the steering wheel. You don't want geometry induced steering, and that's what bump steer is. So really important in my opinion to consider where the drag link is, how long it is, and how that works in relation with the Panhard. Now, if you're swapping Nissan axles into a Defender or a Cruiser or whatever, then you might be changing the factory Panhard, and then you're starting from sort of scratch, so to speak, and you're going to have to customize that all as well. That's fine. I'm not really touching that here. That's you've got to figure it out. So all good. For people that are swapping in with into a Land Rover just to get a stronger box or to get room for an engine conversion, they're still using all their factory stuff, and they're using the factory Panhard and its factory location at the axle. The first thing that's going to happen is, because these sector shafts and Pitman arms mount on the outside of the chassis rail, the drag link is going to get about 150 mil longer than it already is. So that's a substantial change. And then the height. So I haven't looked at the P38 yet, and I'm going to do it in this video. When you mount these in, the height of the drag link changes from factory, from what Land Rover have it as, and that changes the angle of the drag link, because the swivel housing on the axle, that doesn't change. The steering arm on the end of the that's cast into the swivel housing, that doesn't change. So if you change one end, you've changed the angle, you've changed the geometry. So that's really crucial. So I'll either add it to this video or make a second part, but I will put every single box. I'll clamp them up to the chassis here. I'll do the Land Rover box first to show you with the Panhard mount, the relationship. I'll get some measurements. Then I'm going to have to unbolt that mount because it fouls the other two boxes, but I will prop with an axle stand the Panhard exactly where it is to that, and I'll just remove that, leave it, not, be careful not to bump it, and then I'll mount them up, and then we can look at the geometry from the new drag link location with the reality of that being where it is. Now, in saying that, if you're mounting these other boxes, you may change the height of the Panhard. Again, if you have to raise the Panhard, you're making it on a steeper angle. Yes, you'll increase the roll center height, which may have some benefits, but you are creating, at ride height, a bit of an angle on the Panhard, which is undesirable. You can get jacking forces in certain cornering and coming off bumps and unloading with the suspension that is undesirable. The best Panhard would be dead flat at ride height, and as long as you possibly could have it, like, from, in an ideal world, right across, but that packaging doesn't allow that. But the longer the Panhard and the flatter it is at ride height, and then obviously the geometry of the drag link, being in unison with that is what's really important. So we'll look at all that as well. I'll make a part 2, I think, because this is already half an hour long of me just absolutely waffling on. But yeah, some considerations of these boxes for your steering box conversion, whether it be for strength or for an engine swap. But yeah, just some key points, and hopefully it'll help people out there that are looking for that information and couldn't find it like I could. So yeah, cheers guys, have a good one.